This article's author attempted to compare the carbon emissions of hydrogen fuel cell and battery electric vehicles. Henceforth, vehicles will be referred to as FCEVs and BEVs. BEVs are made up of an electric motor, batteries, that powers the motor, which can be charged at home or at a charging station. In contrast, a fuel cell electric vehicle, FCEV, uses a chemical process between oxygen and hydrogen to store power in a battery. For FCEVs, hydrogen is filled in a tank inside the car. In case of an FCEV, stored hydrogen is delivered to the fuel cell to produce energy, whereas in case of BEVs, power flows from the charging units to the vehicle. For BEV, the conventional source for generating electricity is coal, nuclear, gas, and renewable sources are solar, wind. That decides level of carbon emission, whereas, in case of FCEV, what matters is the source from where hydrogen is generated and its production method. Carbon emissions from different power plants. Biomass 340, coal 916, gas 354, hydro 12, nuclear 12, solar 50, wind 10. Hydrogen production methods. Gasification of coal. Grid-powered electrolysis. Biomass gasification. Hydro-powered electrolysis. Nuclear-powered electrolysis. Solar-powered electrolysis. Steam reforming of natural gas. Wind-powered electrolysis. The study was conducted in Romania in the year 2022 on different ranges of vehicle, taking different power mix depending on the various seasons. Power mix is referred as combination of various sources used to generate electricity. The days chosen, depending on seasons were 4th March, 29th April, 11th August, 16th November and 5th December. The vehicles considered for the study were electric vehicles. Dacia Spring, Fiat 500 Electric, Ford Mustang, Mach-E RWD, Hyundai Kona, Kia Niro EV, Peugeot E208, Skoda Enyaq 4, Tesla Model S, Tesla Model Y, Volkswagen ID4, fuel cell electric vehicle, Hyundai Nexo, Toyota Mirai. To calculate and compare the carbon emission by these electric vehicles on different dates, software MATLAB was used. In Romania, in the year 2022, out of 23,221 vehicles that were registered, 10,000 Dacia Spring were consumers' choice. It was assumed that for every vehicle, annual distance traveled is 12,000 kilometers. On analysis, it was found that Mustang e-vehicle is emitting maximum carbon, considering fuel consumption, distance traveled, and Dacia Spring, minimum, of all in all categories, installed capacity, and on all other different dates. It can be seen that Tesla Model S vehicle is emitting maximum carbon considering the range, and Fiat 500, Dacia Spring emitting least carbon in all categories like installed capacity, different dates, etc. In case of FCEV model, Toyota Mirai emit lesser carbon than Hyundai Nexo on basis of fuel consumption, distance traveled and driving range. The study finds that main carbon emission issue with FCEV is that most of the market production of hydrogen is via gasification of coal or by steam reforming of natural gas. Carbon emissions per kilometer by hydrogen-fueled EVs in comparison with BEVs are higher and lower if non-renewable and renewable sources of energy are being utilized respectively. Carbon emission of ICEV, internal combustion engine vehicle, when compared to BEV and FCEV, is higher But, if FCEV uses gasification of coal or grid-powered electrolysis, then carbon emission from FCEV is higher than ICEV. BEV has smaller impact, while FCEV has higher emission impact, if hydrogen production method is from pollutant sources. BEV and FCEV have higher emission during production process. Production of entire vehicles and its emission varies based on different kinds of materials and location of the production facility. Pollution must be evaluated by considering the countries where car parts and storage systems are manufactured. If BEV and FCEV both are considered together, emission from ICEV is more than other vehicles. My takeaway on reading this article: the author has helped readers to understand various sources of generating electricity and hydrogen production methods necessary for an electric vehicle. Further research can be done on these areas. 1. Comparison of carbon emission by BEV and FCEV in other locations or countries. It can be further classified into developed, developing, and underdeveloped countries. It can help to have a comprehensive overview of various power mixes and their effect on the environment. For example, the effect on countries dependent more on non-renewable sources of energy like South Africa, India, and also on the countries that are energy efficient like Switzerland, Brazil, etc. Source: www.ourworldindata.org. 2. How the availability of hydrogen fueling stations and electric charging units will affect the consumer's choice to go for these vehicles. Consumer preferences will help industries to decide on their production and sales forecast. 3. Is it feasible to go with BEV or FCEV? Given that lithium is used for BEV, though lithium helps to reduce carbon emissions, but exploitation of this earth material will be a future concern as it is environmentally degrading.